All right, so I wanted to do a quick little rundown of Excel for those of you who haven't used it or it's been a while since you have used it. So just kind of wanted to show you what I like to see from Excel documents and what I like to see from graphs. So what I'm going to do is I'm just going to get into Excel. I'm going to make up some fake data in lab. You're going to have data that you would have collected. Most of the time in the beginning levels of chemistry, one set of your data is going to represent independent variables. These are going to be your x-axis. And another set of data is going to be, or corresponding data is going to be dependent variables, and those will be in the y-axis. I'm going to make up some data here. Let's just say I'm going to have some absorbance readings at different concentrations. Okay, what I like to do in Excel is I like to make sure that I have everything labeled with as much information as possible. Um, Now, we're not doing an experiment with absorbance and concentration, so this is more about the mechanics of using Excel than what the actual experiment that I'm mimicking is. All right, I like to remind myself what units are everywhere. Couldn't know that with me as a lab professor, so what I'm going to do is I'm just going to make up some data here. So let's say I have a bunch of different concentrations, and I'm good to like two significant figures, 0.12, 0.15, 0.18, 0.25. Okay. And then I'm going to make up, so imagine I did an experiment and I had four different solutions. They all had a different absorbance associated with them. So I'm going to make up some numbers now. So let's say that the absorbance is 0.5, 0.6, 0.41, 0.71, 0.95. Okay. Now, one thing that you should sort of know about Excel is it has no idea what significant figures are. So what I like to do is, let's say I had two significant figures for this column and two significant figures for this column. I would show that on my document. So Excel's not going to do early rounding, which is really nice about it. But what I'm going to come down and do is come down to format cells. I'm going to pick number. I'm going to pick the number of decimal places. And so I'll have Excel actually put in those significant zeros by doing so. This is just really good practice. Again, significant figures are an important thing in science. Let's say I wanted to see if we have a linear relationship between these sets of variables. The way that I'm going to do this is I'm going to select, starting with my x's and pulling over to my y's, I'm going to select both columns of data. I'm going to go into insert. I'm going to hit this little chart right here, which looks like a bunch of dots. Okay, and this is a scatter plot. I'm going to pick the ones where the lines are not connected. Right, this is surprisingly linear because I just made the numbers on the fly. Okay, and you're going to get something that looks like this. Okay, now this is a bit of information, but it's not, an analyzed graph, and so we're going to go over the details associated with that. We're not going to plot these by hand, so these like grid points are meaningless, so I like to kind of delete them just to make our graph look nicer. We like to minimize dead space in our graph, and so dead space would be these areas right here that don't have any dots in them. And so what I'm going to do to focus in on like the main points of my graph is I'm going to double click on this axis. This is the x-axis down here. It brings up this little chart. My first point starts at 0.12, so I give myself a little bit of room, but I'm going to start it at 0.1, and now you can see there's a lot less dead space on this side. And in fact, you could probably go out a little bit further, depending on how picky you wanted to be. That's like a decent amount. If you were just really good about it and start it there, that would be okay too. All right. It's a little bit subjective, but I like to keep just a little bit of room on that left hand or on the side, just to make sure you can kind of get some idea where this point is placed on each axis. All right. Still a lot of dead space on the bottom. I'm going to come here. I'm going to double click on this, come over to this axis options. And then I'm going to change the minimum again. I'm going to take the minimum up to like 0.45. Okay, so that's good. So you can see like at the edges of my graph, there's not a lot of dead space. Maybe we could get away with kind of closing this down. We could take it to 1. Okay, so that looks like a really good graph. It'd be hard for me to take off points for there being too much white space relative to the data that you're analyzing. Oh, sorry, too much dead space on the graph relative to the actual data range that you're analyzing. So what we're going to do at this point is a lot of times we have to do like a linear analysis. So we're going to do that linear analysis, and then we're also going to format the graph correctly. What I'm going to do next is I'm going to click on my data points. You'll see that they're highlighted. They have these like kind of X symbols around. I'm going to right click. I'm going to go to add trend line, right? And then this tool on the side pops up. it starts with a linear, and at this level of chemistry, most of our graphs are going to be, well, I think all of them are going to be linear. And so what we often need is to see what that equation is. So I'm going to come down here and click set the equation on the chart, and then display the r squared value. Okay. The r squared value tells you how linear it is. You can kind of visually see that, all right, because all dots are close to the line. The dots are close to the line. And so we're in a situation now where we can look at this r squared, and it kind of quantifies how close the dots are to the line, and the closer it is to 1, the better. So this is a nice linear graph. Even if it wasn't, it's probably like the only data set that you have or the only model that you're testing a lot of the time. So you would have to use it anyway, but it's good to know and then reference in like a discussion question if it came up. Okay. Now this shows you, all right, the slope and y-intercept. So this form is y equals mx plus b. I think we can blow that up a little bit if we wanted to kind of see it better. Okay. Ooh. Sorry. Yeah, okay. So the y equals mx plus b, whatever is attached to the x as a multiplicative factor is your slope, and whatever is attached to the plus b part is your y-intercept, which is not attached to the x on this side. Again, Excel has no idea about significant figures. So say we had x's and y's that were two significant figures, and that would translate to both the y-intercept and the slope. Kind of just use that abbreviated significant figure rule so that we understand that the error or the uncertainty in our measurements and our calculation correspond and translate to the slope and the intercept that we calculate. Okay. So this graph is kind of close to being done again, but I like to see it formatted well. And what I'm going to do is right click on, I'm going to click on the graph, not right click, but click on the graph, and it'll bring up this little set of tools. I'm going to pick the plus, and I'm going to do some axis titles. Okay. Now, once I check this, you'll notice that it popped up with these little boxes here. And so what I'm going to do is I'm going to label these axes with, well, the variable that they're describing and the actual dimension, the units associated with that variable. So my x-axis was concentration. All right, in molarity, I like to use a slash. Okay, if you did it with parentheses, that's fine as well. Okay, so using a slash or a parentheses tells you, okay, this is the actual thing that you're plotting, what it is in words, and then this is the unit. All right, over here we'll find next semester that absorbance is actually unitless, so I'm just going to label this as absorbance. Okay. And then a big like error that I see students kind of do is with their graph title, they'll come up here and they'll just call this like absorbance versus concentration. And that's kind of nonsensical to do in science because like I can read these axes, like they're here. I don't need like a second reiteration of them, okay? And so a big deal is knowing how to properly like title a graph. And whenever you title your graph, you can kind of think about what you're using the graph for, like what the purpose of it is, or what equation you're using to actually kind of, you know, produce what's here. And so just as a take home, just really succinct point, never just reiterate your axis titles as your overall title. For here, this would be like a Beer's law analysis for molar absorptivity. So where am I getting that from? Well, I'm getting that from the understanding of the experiment I'm describing. So again, what you would do in this situation is you would think about what's the experiment that you're doing, what sort of theory, what sort of idea are you using for this plot, or what information are you getting from your plot. Those sort of ideas are good sort of axis titles whenever you're stuck. Okay. Yeah, so I think this is pretty good. I probably wouldn't be too picky if somebody turned this in. There's a little bit of dead space here that we could maybe get rid of and focus in on more. But again, like you just want to leave me with like little opportunity to actually take off points for that. Yeah, so that looks even better. Like there's nothing I could do here that would take off points. It looks like your axes are labeled. They have the units where they're appropriate. I see your graph. All right, in your work, you would be able to indicate the correct number of significant figures here. My title is here. It's not a reiteration of my axis labels. Okay, so that's sort of like just a quick little graphing introduction. As always with anything, if you have any questions, you can reach out to me. Thanks.